Okay, so it cut off, but here's the last problem. So a project is going to have 3 activities before it's actually complete, and the activities are A, B, and C. I'm just labeling them that, maybe it's like the cutting and dyeing and the finishing like we did on the golf bags, but there's just 3 things before it's done. The time that it takes is the following. Whoops. So for the first project, it's going to take either 5, 6, 7, or 8 weeks. The probability that it takes 5 weeks is 25%, 6 weeks 35%, 7 weeks 25%, and then 8 weeks is 15%. Then after it finishes in A, it's going to go to B, and the amount that it's going to take there is a normal distribution with mean 5 weeks, standard deviation 0.5 weeks. And then lastly, C, and it's uniform between 6 and 8. So it's going to take between 6 and 8 weeks. Everything between the two is equally probable. I want to answer 4 questions. First is, what is the average amount of time it takes to complete the project? What's the minimum completion time? What's the maximum completion time? And what's the probability it takes 18, that should say, weeks? Oops. 18 weeks or less to complete the project. So in SAS, I'm going to call this project. The first question that we're going to answer is, what is the average amount of time it takes to complete the project, right? So average amount of completion time. What I'm going to say in the beginning is that the completion time is 0. Then we're going to do our do loop, and let's do 200 trials. We might as well say that our do loop is going to end, so let's close that off. So do from I equals 1 to 200. So first what I'm going to do is we got to decide how long A takes. So A is probably the hardest of the 3. So what we're going to say is let U be a random number. So let U be a random number between 0 and 1. And we did this in Excel, if you remember, when we were given the probabilities, we did the kind of this if thing. If that random number is less than 0.25, so we could say equal to 0.25, then A equals 5. Else, if U is less than 0.6, then A equals 6. And the way I'm getting that 0.6 is that it's the 0.25 plus the 0.35, which were the first 2 probabilities. So else, if it's less than, we'll say equal to 0.6, then A is going to take 6 weeks. Otherwise, if U is less than or equal to, so the next one would be 0.85, then A equals 7. And then otherwise, if U is less than or equal to 1, then A equals 8. So that's going to give us the completion time in A. And the way that we're reading this is that U is going to be some sort of random number between 0 and 1. If that number is, let's say, 0.9, then it's not going to hit until that last part, because it's not less than 0.6, not less than 0.85, so then A would be 8. Let's say the number was 0.5. Then it's not going to hit the first time, but it does hit the second time, so it hits this line. So A would be 6. So that's how we're reading that. Now once we know A's completion time, we'll do B. So B was a random number. It was normally distributed. Mean was 5. Standard deviation was 0.5. So a little easier than A. C was just trying to make this all look uniform, was a random number. It was uniformly distributed between 6 and 8. Okay, so all we've done now is just randomly generate, and I can show you this. We just randomly generated how long it's going to take in each department, A, B, and C. Let's see what these look like. Oh. don't know if you noticed, but I put an A there. Okay, so the way that we're reading this output is U was just our random number. Remember, that was telling us A, how long it spent in A. So A, 6 weeks, 6 weeks, 6 weeks, 5, 8, you can see we get everything between 5 and 8. Then B, that was, if we go back, that was our normal distribution. So that's where B is coming from. And then C was that uniform distribution. So those are just out of 200 different projects, those are the times it spent in A, B, and C. We want total comp time. So what I'm going to say is that now that we've done that, let the completion time equal the previous completion time plus A plus B plus C. This is going to give us the overall completion time. So in the beginning it was 0. Every time we do a project, we add it to the previous time. So this will give us all of the times totaled. Then my average completion time is going to equal my completion time divided by 200. So let me go to our output data, go to the end, scroll over. So it looks like my average completion time was around 18 and a quarter, 18.3 weeks. The next question is, what is the minimum completion time? So what I'm going to do is go back to my code here. The easiest way to do this is in the beginning, give an outrageous minimum time. So for sure, our minimum is going to be less than 100. It's not going to take over 100 every time. So I'll say that the minimum time is 100 in the very beginning. Then I'll say if the min time was greater than A plus B plus C, then do the following. So if the minimum time that I currently have is bigger than the completion time, then I want to replace the minimum time with that completion time. Otherwise, so else do, the min time will remain the same. So again, the way we're reading this is that if the min time I currently have is bigger than a completion time, so this A plus B plus C, that's a completion time, then replace the min time with the new completion time. Otherwise, keep it the same. And we might as well do the max time while we're here. So in the beginning, I'll let max time be 0 because I for sure know I'm going to get a maximum time bigger than that. So now we'll say if the max time is less than a completion time, then replace max time with that completion time. Otherwise, keep the max time the same that it was. So what this is saying is that if your maximum time is less than a completion time, change the maximum time because it just got bigger. Otherwise, keep it the same. So we can run this. Oh, I missed an end here. So I had forgotten to close my 2 if loops. So the if, the max time, and then, if the min time. So close those 2. Now look at my output data. So I'll go to the very end. The average completion time, still around 18 point something. It looks like the minimum that I got was 15.8 weeks, and the maximum that I got was 21 weeks, just a little over 21 weeks. And the last question, what is the probability it takes 18 weeks or less to complete the project? So let's go back to our code. We've done these before. The first thing I need to do is count the number that is 18 or less. So I'll set it at 0. So the number of 18 is currently at 0. Then I'll say if a completion time is less than or equal to 18, and then do the following. So if it's less than or equal to 18, we'll increase the number of 18 by 1, and then end. Otherwise, so else do, the number of 18 or less is equal to the number of 18 or less. And that's just going to count the number of completion times that were 18 weeks or less. If the completion time was less than or equal to 18, add 1, otherwise leave that number alone. Then once you get that, we'll say the probability of getting 18 or less was equal to the number that was 18 or less divided by 200. And let's run that, and that should hopefully be everything. So let me go to the very end. Scroll over. So my min time, my max time, those are kind of the same. Looks like 87 of the 200 were 18 weeks or less, which gave me the probability of 0.435.